Section 4.1 really is the introduction to polynomials and combining polynomials. You have quite a substantial list of terms that you are expected to know and to use, so make sure that you have read through all of them and that you understand what each one of them mean. On this first problem, all we're doing really is combining like terms. So we'll find everything that is x squared. So here's an x squared, and that's an x squared. And we'll find everything that's x. Here's x. This is x. And then we'll find all of the constants. Please notice that I also circled the subtraction signs and the plus signs. Anytime you see a subtraction sign, that means that this term is negative. You could also think of it as plus a negative 5x. You always order this by the highest degree, meaning that the exponent of 2 is the highest degree, so the x squareds will go first. So we've got negative x squared plus 2x squared, and that gives us positive x squared. Then we've got 3x minus 5x, so that becomes minus 2x. And then finally, we have minus 9 plus 2, that becomes minus 7. On the next problem, we can only combine things that have the same exponents. When we look at this, we'll notice that x squared y squared doesn't exist anywhere else, so there's nothing I can combine. Negative xy to the fourth. Oh, here's an xy to the fourth, so those two terms can be combined. X to the fourth y doesn't exist, x cubed y cubed doesn't exist. So the only thing that we can combine are the two that I've circled. Everything else is simplified. When we write this, what we'll do is write this in decreasing degree of the x term, because x comes first. So for this, we'll write 2x to the fourth y, because that's our highest degree of x. Then we have 5x cubed y cubed. Then we have our x squared, so that's x squared y squared. And then finally, the x to the first power, and that's negative 8 plus 2 is negative 6. Minus 6x y to the fourth. Adding polynomials is pretty simple. We're going to take this polynomial, and we're going to add it to this polynomial. So we're dealing with the same thing of combining like terms. First, I look for the highest degree of x. Here's an x cubed. That would be the highest degree. And there are no other terms, so 2x cubed goes first. Then when I look for my x squared terms, I have negative 3x squared and negative 4x squared, so that becomes negative 7x squared. Then if I look for my x only terms, that's this one, and there are no others, so I would write minus 4x. And then finally my constants. I have plus 9 and minus 5, so that's plus 4. It's harder when we're looking at subtracting because this is something that notation is going to cause you a problem. Subtract this polynomial from this polynomial. So imagine if I said subtract 5 from 10, that means 10 minus 5. So we're going to start with this polynomial minus this one when you write it out. I want the second polynomial in parentheses. because you will have to distribute this negative to each term. And you'll end up with minus 3x squared minus 4x plus 5. This is where most of you will make a mistake, is that you will either forget to make this 4x negative or this 5 positive. Once you're here, you combine like terms. 2x, negative 3x, 2x squared, negative 3x squared, that's negative x squared. Negative 9x, negative 4x, that's minus 13x. 7 and 5, that's plus 12. In 4.2, we're going to be looking at laws of exponents. So what you've seen in the worksheet or in the notes, I'm just going to demonstrate for you here. So here I'm multiplying two terms that have this same base. So they're two exponents. So this is x to the fourth, x to the third. The only time that you can follow this particular rule is when the base is the same. So what ends up happening is I have 2 times x to the fourth, that's 4 x's, times x cubed is 3 more x's. If you count these up, you have 7 x's. Taking a look at the next one, you have 3 times 4. There's your 1x from the 3x. And then you have 5 x's from the 4x to the fifth. 3 times 4, we know that to be 12. And then if we look at all these x's, we have 6 of them. That's x to the 6th power. So the rule is, when you have the same base, and you are multiplying powers, add the exponents. This is what we call the power of a power, or the power of a product. If I take a look at the first one, I have 2a squared and the whole thing is cubed. So I could write that as 2a squared times 2a squared times 2a squared. If I collect all my similar values, so we have 2 times 2 times 2 times a squared times a squared times a squared. 2 times 2 times 2 is 8. And then using the previous rule, a squared times a squared times a squared, we can add these three together, and we would get a to the 6th power. If I look at the next one, ab to the 4th, quantity squared. So that's ab to the 4th times ab to the 4th, which means a times b to the 4th times b to the 4th. And that gives me a squared b to the 8th. And then on this last one, m to the r power, quantity squared, I have m to the r times m to the r. Well, the rule says as long as my base is the same, I can add these two exponents. R plus r is 2r, so this becomes m to the power of 2r. So here's the rule. When you take the power of a product, apply the exponent to each factor, when you take the power of a power, multiply the exponents. What that means, if you look at this first problem, 2 to the third power, 2 times 2 times 2. So you applied this exponent to the 2, and then you had a squared to the third power. You multiplied 3 times 2, which is how you got a to the 6th. All right, so these last two examples sort of combine everything we've done. So we have c to the x power times c to the 5 minus x. So what we need to do is c to the x plus 5 minus x, right? Because they have the same base, so we just add x plus 5 minus x. And we end up with c to the 5th. On this next one, we need to distribute. You guys all know what distributing is. And then we'll use our power rules when we distribute. So we start with 6y squared times y squared. We shouldn't have to expand the whole thing. We know that y squared times y squared, we add our exponents, so we get 6y to the 4th. Then I distribute 6y squared times y. They have the same base. The exponent on y is 1. So 6y squared times y becomes 6y cubed. And then finally, 6y squared times negative 2. 6 times negative 2 is negative 12. And y squared stays the way that it is. Section 4.3 is the last thing we'll deal with in this lesson, and it covers the idea of multiplying products. These three special products that I've listed, you need to have memorized. So if you have a plus b squared, this is the rule. A squared plus 2ab plus b squared. Memorize it. A minus b quantity squared, a squared minus 2ab plus b squared. And then, if you remember when we were verifying trig, a difference of squares. So here's a difference of squares. And when you multiply, or when you factor this, rather when you multiply these two, you get a difference of squares. So it's a plus b times a minus b. You must memorize these three. You guys all know what foiling is, so that's what we're going to do. First, outside, inside, last. So the two first, 2a times 3a, well, that's 6a squared. The two outsides, 2a times 4, that's 8a. The two insides, negative 5 times 3a, that's minus 15a. And then the two last values, negative 5 times 4, that's minus 20. If you notice, these two terms in the middle are like terms, so they can be combined. So we end up with 6a squared minus 7a minus 20. When you have a problem like this next one option that you have is to expand it and FOIL. Otherwise, you can use the rule. A squared, that means 3c quantity squared becomes 9c squared plus 2ab. So I know there's going to be a plus 2 times 3c times 2. 2 times 3c is 6c times 2, that's 12c. And then plus b squared, 2 squared is 4. Taking a look at the next problem, right, 4k plus 7, 4k minus 7, that will be a difference of squares. So it's going to be this a term squared. Well, that's simple enough. 4k times 4k, that's 16, or I could write it correctly. 16k squared minus b squared. 7 times negative 7, that becomes negative 49. This last problem, it's not as difficult as it looks, and if you're organized, you can simply distribute first times first, first times second, first times third, second times first, second times second, second times third. It's not that hard. But I will show you another method. We call this an area model. So I'm going to represent this polynomial vertically here, and that will be 3x plus 1. The second polynomial I will represent horizontally, and that is x squared plus 2x minus 6. And then all you do is complete the area. So x squared times 3x, that's 3x squared. 2x times 3x. Hope you caught the mistake that I just made. That's 3x cubed here. 2x times 3x is 6x squared. And then negative 6 times 3x is negative 18x. You do the same thing on the next row. X squared times 1 is x squared. 2x times 1 is 2x. Negative 6 times 1 is negative 6. And now you combine like terms. 3x cubed stays by itself. And then we can see we have 6x squared plus x squared, that's 7x squared. We have negative 18x and positive 2x, so that's negative 16x. And then negative 6 is also by itself.